Hello friends, let's have a look at today's daily challenge problem. Problem 881, boats to save people. In this video, we're going to explain a solution based on the use of deque abstract data type. Let's first look at the problem statement to digest the requirement. We are given an array called people, where people I is the weight of the ith person. And also, we are given an infinite number of boats, in other words, sufficient, where each boat can carry a maximum weight of limit. So each boat carries at most 2 people at the same time, provided the sum of the weight of those 2 people, or maybe 1, is at most limit. So we are required to return the minimum number of boats to carry every given person. So before we look at the examples, let's also look at the constraints. So the first one is the length of the people list or array. So it's not empty first, and on the other hand, so it can be up to 5 times 10 to the power 4 in length. So this is a decent large number. Secondly, so each of the weight is bounded below by 1 and bounded above by the given limit. And the limit is bounded above again by 3 times 10 to the power 4. So this is an important assumption. That is, people has a positive weight and it's less than or equal to limit, right? In other words, all the single person can be accommodated by 1 boat. So let's look at the examples now. So in the first example, the weights are 1 and 2. And the limit is 3, so we just need to use 1 boat, right? So in the second example, we can use 1 boat for the 3, and then we can use another boat for 2 and a 1, and then the remaining 2 we use the third boat. So in example 3, so we need to use each 4 boats for each one. In other words, each person with a boat. The reason is due to the comparison between the limit and the sum of any two weights, right? So with that said, let's look at the treatment here. Here we want to explain in this way. We are going to sort the people list, so either increasingly or decreasingly, depends on what you like. Here we're going to sort the people decreasingly to fix the idea. And then we convert the people list to a deque. The reason we make this conversion is that we need to do pop operations from both ends. Then our strategy will be continuously doing the following operation. So we pop a weight W from the left, right? From the then we examine its sum with the smallest weight, that is people -1 after sort. Then if W plus people -1 is less than or equal to the limit, then we're going to pop people, the last people. In other words, we can use 1 boat to hold the 2 people. So in this case, we need to increment the boat counting by 1, right? Otherwise, so we increase the boat counting by 1, but we do not pop the last element. In other words, people -1. This means that so we use a single boat to hold the people with W, right? So here is again an explanation. The first corresponds to carry W and people -1 with 1 boat, and the latter carry W only with 1 boat. So with this strategy explained, I guess we are ready to do the coding. So once we grasp the idea, and so doing the coding is a sort of routine. So here first, I'm going to sort the list people in place. So here I'm going to use a reverse equals true. This is a personal preference. You can just sorting from small to large and return large. Regard the tail as the larger one, corresponding to the above left, right? And then we're going to make a type conversion. So we're going to use this container. So people, right? So now the current state of people is actually a deque. And then we are ready to do the strategy. First, I'm going to retrieve the length of this people, because this way I can monitor how many elements are left in the people deque or the iterable. Then we are going to initialize a result variable. So this is the counting variable, counting how many votes we need to hold all the people. So afterwards, we need to return the final state of this result, this variable. And then we are going to do the strategy. Let's do it continuously. So in other words, we are going to use a while loop. While n is greater than 0. In other words, there are still people there. And then we're going to get the larger, or the large one, or the more heavier one. So that's the people pop left. Right. And then as long as we pop, we need to increment the result by 1, because at least we need 1 vote to hold this people. The question is that if we can add 1 more people for this vote, right? And so once we increment the result by 1, then the length is decremented by 1, right? And then we're going to check if we can add 1 more people. So if n equals 0, so in this case, we hold all the people, then we just need to return the result state. Otherwise, so we still have people left. Then we track the tail element, that is people -1. At first, I didn't do the pop operation, right? Because if the current vote cannot hold this extra people, we need to put it back. So here, let's first look at it. So this corresponding to the peak operation, right? So if large plus small is bounded by limit, in other words, less than or equal to the given limit, then we can hold this people. So this corresponds to do a pop operation, right? And then we are going to decrement this length by 1, because we add another people in the current vote. So otherwise, we just continue, right? So let's continue. Yeah. So then we just return the result. Yeah, this short snippet of code forms a solution format to this problem. So before we make any comments, let's first do a check. Yeah, it passes a special one. Now let's look at the generic case. Yeah, it passes all the generic cases. So with that checked, let me make 2 comments. So here, after we do this if, so actually we do not need, in a rigorous sense, this else block. Here we are writing this else block is just to follow our thoughts, right, or reasoning, formal reasoning. Then let's check again. Yeah. Another thing is that you can do thought from here. If you just do the without this one, let me maybe write another version for this one, just to demonstrate the idea. So here, let's just do a thought. We thought from small to large, and then here we just need to use pop, right? And here we are going to pick for people 0, right? And then we are going to pop left, right? Same thing. So now let's do a check. Yeah. Yeah, it passes all the cases. So with that said, I guess that's about it for this daily challenge problem. In this video, we practiced the use of deque abstract data type. So it's a proper container for this problem. For sure, there are many other ways to approach this problem. You're welcome to try and share. With that said, thank you.